Hello student, the question says a coil of area A turns N and carrying current I is placed with its face parallel to the lines of the magnetic induction B. The work done in rotating the coil through an angle of 180 degrees. See, this question, there are some issues. In most of the books, the answer is given as 2IN into AB. But actually, that is wrong because the authors have taken the phase as something else. Generally, when we say the phase is parallel to the lines of magnetic field lines, suppose if this is the phase of a coil, the magnetic field lines is parallel to that. If the magnetic field lines are parallel to that, this will behave like a mini magnet. So the magnetic moment of this coil would be in this direction, and the angle between both of them would be equal to 90 degree. But what most of the authors have considered is that when it is written phase parallel to the lines of the magnetic field lines, in many books it is taken as though this configuration they have taken. This configuration they have taken. They have taken that the initial angle between both of them is 0 degree. But that is wrong. When we say phase of a coil actually means the planar surface. That means phase of a coil means plane of a coil only. Plane of a coil only. It does not mean the perpendicular of a coil. So when we say face of a coil is is taking an angle is parallel to the magnetic field lines, that means he has given the plane of the coil is parallel to the magnetic field lines. If the plane of the coil is parallel to the magnetic field lines, what is the angle between magnetic dipole moment? Magnetic dipole moment would be perpendicular to this. That is, the area vector would be perpendicular to this. So the angle between magnetic dipole moment and the external field lines is not 0 degree, it is 90 degree. So basically, initial angle theta initial is basically 90 degree. Now, what we have done is now we have rotated this by 180 degree. We have taken this is 90 degree rotation. We have rotated it by 180 degree. When we rotate it by 180 degree, the final angle between both of them is also again the angle between both of them. There is no change. Again, the angle between them is 90 degree only. That means if theta initial is 90 degree, theta final also became, there is no change. So again, this one also became 90 degree only. Because if I rotate this, some people take it as 270 degree, but we can just take it as the final angle between them is also again 90 degree. So initially 90 degree, finally also 90 degree. Since initially, finally both are 90 degree, the work done formula is MB cos theta initial minus cos theta final. Since originally also 90 degree, finally also 90 degree, the work done is 0. So the correct answer for this would be option 4. But in most of the books, it is given as 2, which is wrong because they have assumed when we say face of the coil, they have taken with perpendicular to the coil. They have assumed this situation. And then they have taken, rotated it by 180 degree as this situation. And we will get option 1 in that, option 2 in that case. But our goal is to not to get whatever answer it is, like we have to know what is the exact terms that we have to follow. So when we say face of the coil, it means plane of the coil only. So initial angle is 90 degree and work done is 0. Hope you understood how I have solved. Thank you.